Okay, so everybody, what we're going to do today is we're going to
Learn about different cabinets.
quickly rehash law of sines and law of cosines, because we went over that last week, and I think a good refresher of that would be useful.
Yeah, we have to teach all
And
that.
then that should take us through the period, okay? So, we're going to look at the law of sines.
I have a quick question.
Yeah.
Have you looked at the tests at all? Do they look somewhat decent?
I have not, to be honest with you.
Alright.
Who still has to take the test?
Several people do. So, Clark needs to, you need to, Mason, you need to as well. There's like a few there's like one or two other people who need law of sines. And law of cosines. Okay. Alright, so again, what these things are is the law of sines and law of cosines are both ways we can use trigonometry on triangles that aren't right triangles. Okay? The proof of them is not actually that hard to do, so it's in the book if you want to look it up. What we're more interested in is just how you would use them. Okay? And for both law of sines and law of cosines, it works under a similar similar principle. We'll have any random triangle. Doesn't matter what type of triangle it is. Could be a cube, could be obtuse, could be equilateral, could be isosceles, could be scalene. Heck, you can even use the law of sines, law of cosines on a right triangle. Although if you did, it'd be rather silly because the sine and cosine already work for right triangles.
Yes,
Okay.
squared.
So basically, it works for any triangle like so, where we've got. Okay, where you've got angles and side pairs, okay? And you want to think of an angle and the side oppositely, so that's the side the angle opens up to. So big A goes with little a, big B goes with little b, big C goes with little c, okay? Now, law of sines is probably the easier of the two to set up because it's really straightforward. What the law of sines says is that basically, for any triangle ABC, such as this one right here, the relationship between the sides and the angles are as follows. Basically, that side A divided by the sine of angle A is equal to side B divided by the sine of angle B, which is equal to side C divided by the sine of angle C. Okay.
So they're all equal?
They're all equal to each other. They're all in ratio to each other. Okay. So you'll see some sources write these actually flipped upside down. I think the book actually has it this way as well.
I think they do.
Which is fine. It means the same exact thing. Remember, these things are all ratios, so it doesn't matter.
It's just a little confusing when they switch it up like that.
Okay. Well, just realize it's just meaning the same thing.
Yeah.
Okay. So really, it doesn't matter which version you use or how you use it, as long as you keep. If I'm using it where I'm putting the angles in the bottom, I just keep the angles in the
As
bottom.
long as you just keep it straight.
Right.
Yeah.
Okay.
That's math
so-
for you.
That's the law of sines, really right there. It's just a regular ratio. You just enter the information in. In order for the law of sines to work, again, you always need a side angle pair. Okay. So basically, to use law of sines, you always
You need a big A and a little A.
have to have a side angle pair. Yep, so you need a big A and a little a, okay? Or a big B and a little b, okay? Or something like that, okay? Then whatever third piece, and then obviously some third piece of information. And with Dowell, that you can solve, okay? There are a few hiccups with the law of sines that we'll look at here in a second. The first one is that it doesn't necessarily, I shouldn't say that it doesn't always work. It's just that there could be situations where there ends up being two answers. Yeah, there are two triangles in which could give us the same example. We'll go over that in a second. There are also situations where you could be given information about a system, and it turns out the system doesn't actually make a triangle, and so the law of sines will kind of lie to you, basically. And so you do have to keep that in mind, the law of sines, okay? So we'll go over those when we do some examples here in a moment, okay? The other law here is the law of cosines, okay? And the setup for it is going to be exactly the same. So the same type of idea with the triangle is going to apply, okay? With this angle big A, angle big C, angle big B, etc. Okay. The law of sines, though, is not a ratio like the law of the law of cosines is not a ratio like the law of sines. It's instead a formula, okay? And it's one that actually is fairly familiar if you think about it, okay? There's two different versions of it. Version 1, you can think of it. You can think of this as 4 sides. Is the standard a squared is equal to b squared plus c squared minus 2ab cosine of big A, okay? And technically speaking, the full law, oh, I'm messing this sign up here, it's 2bc, excuse me. Okay. And then the last, okay. Technically speaking, the full law is all 3 of these formulas. From a practical standpoint, obviously, if you just know the top one, you basically can, any triangle you can solve using the law of cosines.
So this creates angle with pairs, right?
Yep. So, and that's the other thing. Yeah. So with this one, you need a side angle pair. With law of cosines, you're finding a side angle pair. You've got the side, you want the angle, or you've got the angle, you want the side. Okay, is what the law of cosines does. Okay, the other version of it is basically taking this and rewriting it. You can think of it as 4 angles. It basically says that the cosine of A is equal to b squared plus c squared minus a squared over 2bc, okay? And you can go down the list just like so. So you could do it for side B, etc. Okay, I'm just going to write etc. because I'm going to write all. Okay. Nice thing about the law of cosines, always works. Okay, so if you have a triangle that you could use the law of cosines on, law of cosines will work for it. Okay. So you don't have to worry, so it's not like the law of sines where you only get one answer, or you could, it's not like the law of sines where you could possibly get 2 answers, or you could be given information and it not end up being a triangle. For law of cosines, if you're given information, it has to be a triangle, or if you tried to use the law of cosines on something that wasn't, it would just say no answer, basically. That's what it would come back with. And you're only ever going to get one triangle, okay? Kind of the downsides about the law of cosines is it's much more complex, okay? Because as you can see here, it's using like everything in it, while these are just simple ratios. Law of cosines is a long formula you have to work out, so that's something to keep in mind, okay? Although, what's interesting about the law of cosines that you can notice already by looking at it, it looks like what?
Pythagorean theorem.
Pythagorean theorem. In fact,
It's the first half.
you could show, you could demonstrate a
Right,
proof,
Carl?
an easy proof of Pythagorean theorem comes from this. The cosine of 90 degrees, or the cosine of pi over 2 is 0. So on a right triangle, which is what the Pythagorean theorem is for,
What? Just keep falling.
each of these would be equal to 0. And so you'd be left with a squared, or like a squared equals b squared plus c squared. Okay, and it would work out every time. Okay.
May I go to the bathroom, please?
Yes. Okay. Any questions about that?
No.
Okay.
No.
Let's take a look at some actual triangles solved this
Oh,
way.
wait,
Isn't it both?
So to solve for the angle with like arc cosine.
Yeah.
Down.
Yeah. Okay. Sweet. If we're solving. Okay. All right. So examples here. Okay. We'll do law of sines first. Okay. So let's say I had any random triangle here. Okay. We're going to make this 40 degrees up here. Call this side here 5. We'll call this side angle B, and we'll make this side here 7, okay? Angle C, so, okay? And we want to solve this triangle. That is, we want to find all the pieces of this triangle, okay? What we would do here, basically, is set up the law of sines. I would just basically say 5 is to the sine of 40 as, in this case, 7 is to the sine of whatever B is, okay? Now, in this particular case here, okay, we don't know if side 5 and angle 40 is the smallest side angle pair or the middle-sized side angle pair, okay? So because of that, we could actually end up with 2 different answers here, okay? So we'd have to work this out here and understand kind of what our answer is telling us, okay? So we solve this ratio here. It's fairly straightforward. It would just be cross multiply. So 7 sine of 40 equals 5 sine of B. That means 7 sine 40 over 5 is equal to the sine of B. Okay? Which means that B is equal to the arc sine of 7 sine 40 all over 5. Okay? So we get a calculator out. Okay? We're using degrees, so let's make sure we're in degrees. We just enter an arc sine of 7 sine 40, close parentheses, divided by 5, close parentheses. And we get that B here, we did this directly, is equal to 64.145 degrees. Okay? That's one possible answer for it. The other possible answer would be 180 minus this angle. So 180 minus 64.145, okay? Or 115.855 degrees, okay? There's 2 answers here because we don't know if this here is the big side, or basically it's the smallest side angle pair, or the middle side angle pair, okay? If it's the, so that can affect our answer, okay? If it's the smallest, this is our answer. If it's the middle, this should be our answer down there.
Wait, sorry. How do we find 115?
We just did 180 minus 64,
perfect.
okay? So, let me write that up there. So it's 180 minus 64.45 degrees. Okay. All right. Now, to find the nice thing about that is, once we have our second angle, we can find the other 2 by simply just using the fact there's 180 degrees in a triangle. Okay. So, angle C then is going to be either 180 minus 40 minus 64.145. So this is either going to be 75.855 degrees, or, okay, 180 minus 5 minus 40, or it's going to be 24.145 degrees. Okay, and again, it just depends on which one we're dealing with. Okay, so if B is 64, this angle is 75. If B is 115, that angle is 24. Okay, that's how you can end up getting 2 answers there. Okay, and then to find side C, you just use the law of sines again with this angle, with these numbers, and you would get C. Okay. So in one case, C is going to be bigger than 5 and 7, and in the other case, it's going to be smaller than 5 and 7. Okay? But that's how you would figure this out. Okay? Any questions on how the law of sines works? It's pretty straightforward, right? It's not that hard to use. Okay? Again, okay, the only time you have to worry about 2 different answers here is if it's ambiguous as to whether or not your pair is the smallest or is the smallest or not. Okay, basically, whether this is the smallest side.
So if C was defined this way,
Yeah.
I have no problem at all.
Exactly. Okay. Or likewise, had this been 8 instead of 5,
Oh,
with the other side being 7, we'd automatically know
that's the biggest.
it's not that it's the biggest side, but it's not the smallest side.
Yeah. Oh,
And then therefore the other two things would have to come out. There would only be one other solution for that. Okay.
okay.
It's only ambiguous as to when you're not sure if the side angle pair you're given is the smallest. Okay. So if the angle here, the side 5, if that had been bigger than 7, then there would only be one case to work out. Or if instead we had 2 angles and the angle was bigger, it would work out that way. Also, too, you could end up with, nicely done, okay? You could also end up with an angle situation as well, where if you're given 2 angles, you can actually just find the other one using 180 degrees.
So 2 angles.
There's only one situation there. Okay. All right, that's how the law of sines works. Any questions there? All right, let's take a look at law of cosines. Okay. Okay, law of cosines. You'll read that this works specifically for side angle side or side 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 triangles. Okay, I guess that's true. It's something nice to know. Okay, for those sorts of situations there. Okay, but basically, how this law of cosines works is, again, setup is very similar. You'll have a situation where you'll have one of those 2 types of triangles. So we'll go ahead and make a triangle here. We're going to find angle C here. We'll say this is 110 degrees. Okay. We're going to look for side C. We're told the other 2 sides here are 7 and 12 respectively. Okay.
That's when you use cosines.
So this would be a side angle side triangle, so we'd use law of cosines.
Yes, sir.
And in this case, we would use, because we're finding a side, we would use the first version of it, is what we want to use. Okay? So how we set this up is we enter in exactly as is.
Yep.
Side C squared is going to be equal to 7 squared plus 12 squared minus 2 times 7 times 12 times the cosine of 110. And nice thing about this is
Calculator.
you could actually just jam that all in the calculator. Okay? So we could just set this in through 7 squared plus 12 squared minus 2 times 7 times 12, times the cosine of 110. Does it say it gives you an answer? You just take the square root of that answer.
Oh, yeah.
Okay? And you get an answer here. So doing all this out here, I got that C then was equal to 15.826. That's what I got. You're getting a different answer. I don't know why that's the case.
Yeah, I might have. I'll try.
Okay. So, yeah. A lot of times, too, when you get different answers when it comes to law of cosines, it's because you try to calculate too much at once. Okay? So if you need to, I always suggest people just break it apart into little chunks and then do the little chunks there. Okay? Especially if your calculator doesn't play by standard rules. My calculator is one you can just enter in everything algebraically. Okay. All right. Now, once I found that as the side, to find the missing angles, what do you think I would do? Would I use the law of cosines again?
Or sine.
I could, but it would be a lot easier. Law of sines. Why? Because it's a simple ratio. Okay. So if I wanted to find this angle up here, I'd just use the law of sines and find it. Okay. All right. So that's one way of using law of cosines. The other way to see this done, okay, the second example of this, again, is for a triangle that's side, side, side. So it might be a triangle like 5, 9, and 12. Okay? And we want to find the sides of this triangle. Okay? So let's say I want to find this side, sorry, not the sides, the angles. Let's say I want to find this angle right there. Okay? In this particular case, I'm going to use the second version of the law of cosines. Okay? Now I could use the first version. Just means I'm going to have to do an extra few algebraic steps. Okay? There's no difference between, really, when it comes down to it, there's no difference between version 1 and version 2. They're the same process. It's just version 2 there has all the algebra steps done for you. So it just allows you just to dump everything in. Okay? So basically, with version 2, it says that the cosine of angle A is going to be equal to 5 squared plus 9 squared. Oops, no, sorry,
9 squared.
12. Yeah, plus 12 squared minus 9 squared all over 2 times 5 times 12. Okay? So we figure out what that number is. Again, we just use a calculator at this point. So it's 25, 25 plus 144 minus 81. Divide that by 120. Okay, so I get the cosine of A is equal to 0.73 repeating. So we just take the arc cosine of that. We get our answer. And I get 42. Okay? So just like that. All right. So that's 42 degrees. Then how would I find the other angles? I can do the same thing again, or use law of sines at that point. Okay? Once you've got one of the angles, once you have a side angle pair, you can always just switch over to law of sines, which people find would be easier to use. Okay? So that's the law of sines and the law of cosines. Okay? And that's everything there is to know about each. Okay?
The law of tangents.
There is no law of tangents. Okay? As far as I have not seen a law of tangents. There might be a law of tangents. Okay? Kind of a consequence of this right here, okay, is something else we can use. Okay? It's a direct result of the law of cosines. It's called Heron's formula. Okay? Yeah. This allows us to find the area of a triangle without having the base and the height. Okay? So for any triangle, again, actually the angles don't matter for Heron's formula. A, B, C. Okay? So for any triangle, okay, what we could do first is we can establish, we would say that basically we'd establish this constant for the triangle called S. S is going to be equal to A plus B plus C all divided by 2. Okay? I want to make sure I'm writing this one down. Incorrect stuff, yes. Okay? And then the area of the triangle is equal to the square root of S times S minus A, S minus B, and S minus C. Okay? Square root of all that. Okay? And that will give you the area of the triangle. Okay? So I no longer need to find the height of the triangle or determine what its base is or do anything like that. If I've got the 3 sides of the triangle, I can dump it into this formula and always have the area. Okay? So an example here, let's do an example of one that, of a right triangle, actually. So it doesn't matter what the triangle is. Okay? So we'll do the 3, 4, 5 triangle. Okay? Now, we already know what the area of this triangle should be, right? What should it be? 6 units, because 3 times 4 is 12, 12 divided by 2 is 6. We should be good there. Let's show that Heron's formula will work fine on this one, okay? So instead of doing it the usual way, let's use Heron's formula. So it's going to be 3 plus 4 plus 5 all over 2. That's 7, okay? 7 times, 7 plus 5, so that's 12 over 2. So we get that S is equal to 6. Then the area should be the square root of 6 times 6 minus 3, or 3, times 6 minus 4, or 2, times 6 minus 5, or 1, which would be the root of 36, which gives us the correct area of 6. Okay. So even with a triangle, we knew. So basically, it would work. So that was nice for that right triangle. But if I had any random weird triangle, okay. So let's do another example of this. The one I had done earlier, 9, 5, and 12. Okay. We wanted the area of this triangle here. I would do, say, S is equal to 12 plus 9 plus 5 over 2. Let's see, that's 14 plus 12, so 26 over 2, that's 13. Okay, so then the area would be equal to root 13 times 13 minus 5, which is what, 8? No. Yeah, 8. Okay. 13 minus 9, which is 4. Okay. And 13 minus 12, which is 1. Okay. And you just enter that in the calculator. Okay. So 13 times 8 times 4. 416. Take the square root of that. The area is approximately equal to 20.396 units squared. Okay. All right. Any questions? All right. That takes care of those things. So we are out of time for today. Okay. According to the clock on the wall.
Good time.
Okay. So there'll be some homework posted tonight on all these questions. It should be really easy. Okay.